thank you so much for being with me during the nap time session. It's both early enough that you could have taken a nap and late enough that you could have started drinking. So the fact that you're here I'm especially grateful. I'm Diana Montalion. I'm a systems architect. I have an organization where we do systems design and also create learning experiences for learning how to think in systems. And because it feels weird to me to introduce myself just by my resume, so these are my dogs. This is Theodore Roosevelt, Winston Churchill, and Maximilian Robespierre. I bet you can guess which dog thinks they're in charge. Yeah? Also, this is me. So I started as a back-end engineer. I helped build the monoliths, and I'm not sorry, because at the time it was the right thing to do. But increasingly, I was the person in the doorway. As relational complexity I work in digital information systems, and the rate of change in the complexity of our software systems and the problems that we were solving increased, I was also increasingly hard-pressed to know how to translate that into software. And simultaneously, I worked on some very big digital transformation. Organizations would say, we need modernization, we need decoupling, we need cloud-native architecture. And they generally ended up like this. So I became very interested in what is this iceberg that we're hitting? Why? Why are we struggling to make these changes? So the name for the talk came when a young man sat down next to me when I was giving a talk at an architecture conference in 2019 and said, "Oh, you're an architect. I want to be an architect too, but I don't know enough about Kubernetes yet." And I thought, okay, I wish that was the answer. I wish I could look back at these experiences and say, you know what, we just didn't know enough about Kubernetes. And if we did, everything would have been fine. But generally, that wasn't the challenge. And one of the reasons is because of Conway's law, which has fit every software system that I've seen, which is organizations who design systems will design systems that are copies of their communication structures. And this makes sense, right? What's in production that we didn't think about and talk about, right? Everything in production is the outcome of our thinking together. And if we want to change what's in production, it kind of doesn't make sense to not change also our thinking and communication. And also the reason that the young man was destined for disappointment is our software systems are socio-technical. Meaning that what we think is all, and what we communicate about, what people do, how people are organized, is going to architect the software system and vice versa. So our behaviors and our ideas and our core beliefs design the system, but then also so does the software. I often get asked to create magic with the cloud, right? Oh, if we go to the cloud, we will be able to achieve all of our goals. But in fact, technology often, the tool set isn't there to do the things we can imagine it doing, AI. So they're constantly pushing back on each other. What the organizations are really asking for is enterprise transformation without the risk of culture change. If you've not seen this snarky little website, sadmf.com, definitely explore it. If you're suffering pain, you might feel at least that you're not alone in your pain. And so this really put me on a quest. So what are the skills that I need to architect modern systems? What, if it isn't strictly Kubernetes skills, what is it? And so for me, these are 5 core practices, there are more, that I rely on all the time. And I think we rely on more than we know. Not all of them we think of as tech skills. So that's kind of our first step, is that maybe we have been too limited in our definition of what we need now in order to succeed. So how many people work in the same tech stack, same language, same tools as they did a year ago? 5 years ago? 10 years ago? 1. Okay. Right. So the rate of change is so quick that we are, if architect is expertise in one particular tool, but none of us work on the same tool for 5 or 10 years, then then how could we architect? Can we still architect if we move to a different group of tech, of tools? So the first one is expand your thinking tool set. So we have been taught, conditioned, and reinforced to think linearly. When we say thinking, usually what we mean is linear thinking. Rational, top-down, procedural, predictable, and concerned with control. Does anyone not experience this in their work organization? Yeah. So this is reductionism. Reductionism has been with us for a very, very long time. And it is the idea that you can break a complex system into parts, which is fine. But it's also the idea that by knowing the parts, you understand the whole. Less fine. And we're going to explore a little bit about why. So this is not a talk against linear thinking, because we need it. And reductionism, we need it. These are really important skills. This is a talk that we need an increasing diversity of thinking skills as knowledge workers as part of our toolbox. Donella Meadows, who wrote Thinking in Systems, which is a terrific book, says that systems can't be controlled, but they can be designed and redesigned. And so as an architect, my goal is to have impact rather than control. Now, sometimes in order to have impact, I need to have control. So again, they're not a binary. But what happens is the more chaos is happening, most organizations default to adding more control, like adding more software engineers to a late project makes it later, right? Which we know from experience, but still seems like a reasonable idea. So I'm making the radical assertion that architecting systems requires systems thinking. And that if we're not developing the ability to think in systems, we're going to be increasingly frustrated by how our thinking tool set isn't scaling. Now, the challenge is, often when you have this tool set, you end up playing glue roles, right? Where your job is to have people and circumstances that don't want to get along, and you're somehow making an artifact to make them get along. And I love this. I tried to organize a stampede, but everyone has their own agenda. I feel like that's most of my career. And these skills that we're talking about, especially changing and increasing your thinking skills, doesn't really matter if your role is an architect, because what we need is less cat herding, less cats. Fewer cats. Like, it isn't just that we have cat herding roles, it's that we're conditioned to also play the role of the cat. And that what we're looking for instead is the flexibility to sometimes be deeply focused on how to linearize or deeply focused on the parts. But as a systems architect, I also need to think about interconnectedness. I need to think about relationships. I think a lot about emergence. Emergence is you have one team building one part of the software, and you have another team building another part of the software. Can the two parts do something neither could do alone? That's actually, from a systems point of view, that's the success criteria, is that the relationships also give you value, not just the parts themselves. We're going to talk about synthesizing because that's really important. And the idea is we need some understanding of the whole in order to make sense of the parts. So we're discerning when to apply reductionistic and analytical thinking, linear, and when to take a systemic perspective. This might be systems thinking, pattern thinking. Edward de Bono has the thinking hats. Collective modeling. Every time you open a Miro board and start moving around sticky notes, you're doing a slightly different type of thinking than, say, a Gantt chart might represent. So I would argue that architecture is less of a job and more of a practice. And it's a practice we'll be doing our entire lives, because here's the unfortunate thing. When you're in one situation and you figure out what to do, and then you go to another situation and you think you know what to do, you're probably not correct. Because every system is going to have some similar patterns and some unique patterns. So we never reach the end. We are always learning and growing. And one of the most important things that we practice is metacognition. So I have adapted Conway's law to say that people who design systems will produce copies of their thinking and communication patterns, right? You are the foundational system of thinking. If you're not able to work with and be aware of how you think, how you learn, when do you think in logical fallacies, what kind of cognitive biases you have, you won't actually be able to then help to change the environment around you. And here's the challenge, though. We have decades of system science, decades of people working with organizations and with groups to understand what happens as relational complexity increases. And we know one thing without a doubt. That is, we blame, and we blame the wrong thing. So a reason metacognition is so important is that right now, you're sure about something and you're wrong. And so it gives us some space to understand that the first thing we blame is something we have to investigate rather than completely trust. And so what we're learning to do is recognize our reactions. I feel some days like it's a major win if I don't bite anybody. Like, if I don't go to a meeting and really want to bite someone. And when I hear things that are truly problematic, what I've discovered is that if I react to them, I often just add to the noise and I don't get what I need. And so instead, it's the practice of learning how to respond to other people's thinking, to organizational thinking, in ways that you can increase your impact. So another reason this is very important is that bugs in our thinking produce bugs in our architecture. So I'm going to give a couple of examples. So Hollis recommends offloading complexity by using cloud-native tools. And Breyer says Hollis hates open source. So what's happening here? Right? We are not engaging with the recommendation to use cloud-native tools, right? Breyer has attacked the person instead of responded to the argument. This happens so often, we sometimes don't realize it. This is also an example of straw man. We love our straw man. Straw man is when we make up an irrelevant argument so we can stab it with the pitchforks of our opinion. And if you don't know what this looks like, watch the American election cycle. You'll find many, many examples. So Hollis recommends building a new capability using microservices and has detailed reasons that support this recommendation. And Breyer says, we tried microservices and it was a disaster. So what's happening here? Past performance does not predict future outcomes. But also, they probably learned something, right? They probably learned something that they can apply here, right? So the fact that it didn't work last time does not just automatically cross out the idea as valid. One more. This is so familiar you might not even recognize it as a fallacy. So Hollis shares a new data model that serves the evolving circumstances, and Breyer says that looks like a graph, and graphs don't scale. Right? This is one line from a giant request for comments. In real life, I asked Breyer what made them think that, and they said, I worked for Google. I worked for Google is not sufficient, not a sufficient justification. So this is burden of proof. So Breyer has not actually given reasons that show how they came to that conclusion, but also they're not responding to why this idea to build this graph is likely to run into problems in this circumstance. And so this is a cat example, right? This is Breyer being a cat. And in fact, all of us together are learning how to share a more sufficient level of systemic reasoning when we are having conversations about what to do. And most of this happens in our own minds, and it's the first place for us to begin to notice. So architecture is not opinion giving. And opinion giving is so much fun. I mean, I'm sure we're doing it here, right? Like, we like to get together and argue about which front-end framework is better or faster or right or wrong. But opinions are not architecture. They're good and they're important, but we're doing more when we are professionally engaging with our knowledge and other people's knowledge. So the antithesis of this is systemic reasoning. So systemic reasoning is, like it sounds, reasoning systematically in support of an action or idea. This is what we do when we don't know what to do. Now, if we know exactly where the problem is, it's in line 733 in this particular code base, and if we fix the loop that we did wrong, it'll be fine. Cool, then that's what we should do. But increasingly, there are many things that we could do. How do we come to some conclusion about how to act? Because architecture is about the action, right? It's not about endless bike shedding about all the things and designing for 40 years until you figure out what to do. And this way, we rely on systemic reasoning, meaning, can we come to the best possible conclusion under the circumstances, based on what we can know, when conditions are uncertain? And this is a little secret about almost every situation. Conditions are always uncertain. We'd love the illusion that we have control and that whatever we want will magically manifest in exactly the way we want it. But I think if you've been in the industry for more than 30 seconds, you've already had an experience where that doesn't always work out that way. And so as complexity increases, so does uncertainty. But that's okay, right? Because as architects, we accept uncertainty as natural, welcome, and inevitable. Right? Right? Don't we? Yeah? Yeah. Okay. We do. We don't. But we want to. So systemic reasoning is synthesizing knowledge, experience, and sound judgment into recommendations based on valid reasoning. The reason synthesizing is here, and you might remember it from the tools of a systems thinker, is that it is usually, as we have more and more parts of a software system, there isn't one person who knows everything. If I, as an architect, limit the teams that I work with and my colleagues based only on what I know, that is as good as the system is ever going to be. But if I'm able to synthesize a business point of view, the product point of view, engineering point of view, and actually figure out what really matters and be able to describe it so other people can also understand why this really matters, I am going to increase my impact. So our recommendations would include the idea, action, or theory. But they also include reliable, relevant, sound, and cogent reasons that justify. In other words, is this true, what I'm saying? Is it sufficient? Have I described it so that we understand the vocabulary? Because walk into a room and talk about agile and watch what happens, right? Because we define that very differently, and we have very different experiences with it. So part of synthesizing is also bringing together and creating a shared language about what it is that we're trying to do. In your reasoning, you also need to describe why we want to do this, right? And keeping in mind that any organization could do 700 million things at any given time. Why is it important now, right? Why will this help us meet our goal? And why is it something worth our time, energy, and attention right now? Because something might be a fabulous idea, but not right now, right? As Kent was saying earlier, if you can push something off, there's also value in not doing if you don't have to do it right now. And we as engineers, we struggle with this a lot. I was in an architecture meeting and one of the architects was saying, we need Kubernetes, we need Kubernetes. And I said, why? And he said, because we don't have Kubernetes. Going to be hard to get the budget based on that. We're going to need to actually think about what is it in this system what's holding the system back? And is it that we don't have good orchestration of containers? Then yes, we absolutely need Kubernetes. But people make arguments. The API is too slow. It needs to be faster. In a circumstance where speed is not really a factor, we just like it. Or the ops guy once who said, 5 nines, Diana, we need 5 nines. Why? Because 5 nines. I mean, that's what matters. So we're also thinking about and discerning whether or not the thing that we're recommending really does matter in our current circumstances. And we're integrating other people's point of view. So you can never I have a lot of people, wonderful people in my life who help me to communicate my recommendations because I think that I'm speaking like a normal person. And then the business person looks at my ideas and says, geek speak. We don't even know what the hell that is, and helps me to be able to look at the problem from different points of view and understand that different parts, like maybe the user is being impacted, or maybe the engineering team is being impacted. There are many ways that a system can feel very different to different people. You might have the best software you ever wrote with the most beautiful code you ever wrote, but it's not making any money, right? Depending on how you look at a system, you're going to see different things. And so this is why an architecture practice, from my point of view, includes structuring discovery, learning, and exploration with others proactively. I need your knowledge. I need other people's point of view. I need other people's expertise in order to improve my own. And also, I'm wrong. Not a lot, but occasionally I'm wrong. And I need other people's point of view to help me to see where I'm wrong. So when we're doing this, we are prioritizing knowledge flow over knowledge stock. This is very challenging to us because what does a whiteboard test? A whiteboard tests what you already know. But how few hands were up when we got to the 5-year mark? So how valuable is what you already know compared to how able you are to learn and grow and use your expertise and your knowledge to help other people also grow their knowledge so that together we can make impactful decisions? And this is more important than you might think that it is. Larry Prusak, who was a professor in knowledge management, worked with NASA, lots of big organizations, and he says that those companies that don't adapt to understanding that knowledge is a force of production, code is knowledge. We're creating knowledge. They'll slowly die and they'll never know what killed them. So we're experiencing this now, especially in the current climate where the idea is if you increase productivity by adding more control, you'll get there faster. But in fact, if you increase the ability for people to share knowledge in ways that actually help them have more impact, you will get there faster. And so this means, well, first I want to say, as a modern architect, the question for me is more like, can you learn new things and adapt to new circumstances? Because circumstances are changing so quickly. And the biggest reason that they are is because the relationships in a system are having more impact than you might recognize. But certainly it's the most impactful aspect of the system. We focus on the parts, but it is what happens between the parts. I say, and it's so true, that it's a great day when the bug in production is in code, because we can fix the code. But it's often in eventual consistency, or caching this way then not that way, or asynchronousness, a place that we didn't think to create observability. So Akoff says that a system is never the sum of its parts. It's a product of its interactions. And so as a modern architect, we're understanding how relationships produce effect, how the interaction between parts is also its own thing. And this is where we get enterprise integration patterns and these kinds of things. But it also is relationship between teams. Or I worked at an organization where tech hated product and product hated tech. And they were surprised by the idea that this might be inhibiting their ability to produce good outcomes. So Donella Meadows says that you think that you understand one, then you must therefore understand two, because one and one make two. But you forget that you must also understand and. And for me, this is the art and science of modern architecture, understanding the and. How, when you put two parts together, two software parts, two teams, 1,000 microservices, whatever it might be, what is happening as a result of those relationships? So you may have seen software systems that contain many good but independent and uncoordinated ideas. I've never seen a software system that doesn't fit this description. Many good but independent and uncoordinated ideas. Most systems I work on now are duct taped. We needed this, then we needed that. And so when I do workshops in the model of the fictitious company, I have little minions. And the minions are the people that are actually compensating for the fact that the parts don't actually communicate. So Fred Brooks said this in the Mythical Man Month, and this is what he describes as the opposite of conceptual integrity. Conceptual integrity is the most important consideration in systems design. And by this we mean the relationships between our thinking process and the people in the system will design the relationships in the technology system and vice versa. Again, the socio-technical loop of their impacting each other. He did say that this means that one person should design the entire system. I do not agree with this, at least not in my experience. And instead, what we're really doing is developing practices and processes and ways of working together that more naturally generate conceptual integrity rather than generate us versus them, and we draw a moat around it, and our alligators will eat you if you try and come into our space. So this is hard stuff already. Yeah, this is hard stuff. And I'm sorry to say it gets harder from here. That also the biggest impact you can have on a system is to shift the paradigm when it's necessary. Now, my son hates this word because he's like, that's just marketing gobbledygook, Mom. You're just like blah, 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 paradigm, paradigm, paradigm. But in systems, paradigm means the rules and structures and patterns and mental models and beliefs that give rise to a system. So one of the things that is kind of it's sort of a secret, at least it was something I found hard to grok, and so maybe you haven't discovered it yet, is that the call is coming from inside the house. Most of the pain that we experience in our software systems, in our big balls of mud, in our organizations, are actually arising from our basic beliefs, our structures, the way we hire, and the patterns. And then when we have a bug in production, what do? We blame the wrong thing, right? And so it's people will say, oh, you're too abstract, Diana. You're too abstract. You need to be more concrete. If I had $1 for every time someone said the word concrete to me, I wouldn't have to be here. I could be reading my Kobo on the beach, right? But concrete is very, very, very important, right? There's no, I don't mean judgment by this. What I mean is that if you buy 4 acres and you were asked me to be a literal architect to design where the house would go and the other outbuildings, you'd want me to be very careful about where I poured the concrete. Concrete is very hard to change. And so many, 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 many times, people want me to begin pouring the concrete. Just walk onto the property and pour some concrete. But then we're stuck with that, right? So sometimes the core mental model, the paradigm shift, is to consider other ways of thinking and exploring before we decide where the concrete idea is going to go. We're generating the problems that we're trying to solve. So an example that is also me, and the thing I love about this is that I was both. I was a CRUD programmer, and now I mostly work in events systems. And this is a shift in paradigm, meaning the reason CRUD is increasingly becoming events is because information is now ubiquitous. We used to have a website. You'd build, I built enterprise digital web presence, and the goal was to have everyone come over to your house. I'm going to publish an article, and we're going to track how many people come and view the page. But now, when people publish information, it often goes to many different platforms and products, news aggregators and social media, and you want different information if you ask Alexa a question than if you read an entire Wikipedia page. And so everything depends on context. It's no longer write something, save it, it displays. Now it's you create content, and there's a whole bunch of things that happen in their own time. So the paradigm shifted around us, and then we have to figure out how to be graceful about that. How do we adapt? And what we do instead is this. We fight about. One engineer said to me, no, Diana, MySQL forever. But I'm sorry to tell you, there's no such thing as forever in technology. So Pirsig says that the true system, the real system, is our construction of systematic thought itself, of rationality itself. And we made all of this up. We made up CRUD. We made up events. We made up Kafka. We made up Agile. We made up Kubernetes, even Kubernetes. And that value streams, you're hearing this, I'm hearing this a lot now, value streams, like this is the new thing. And there's nothing wrong with these things that we made up to solve a problem. They often are addressing a very real problem. But if we've made it up, then we can evolve it. But the only way to evolve it is to change the systematic rationality that that we've become used to as we've gotten to know it. And he goes on to say that if a factory is torn down, but the rationality which produced it is left standing, enterprise transformation without the risk of culture change, then that rationality will simply produce another factory. So maybe you have a similar experience to me. When we moved out of monolithic software into microservices, a few months later we discovered our microservices are very tightly coupled because our brains were very tightly coupled. We had not yet shifted to understanding orchestrating asynchronous systems. The relationships in microservices, the information sharing, the time, it becomes more quantum and less Gantt chart. And it took us time to understand how to shift the rationality to meet more of the challenges that we were facing. And this is totally fine. By the third time, they were much less tightly coupled, though I confess I'm still learning. So when there is a bug in production, for example, there are patterns that are helping to give rise to the bug. And there are also structures within the organization, the way that teams communicate, the way that we hire, how we work together remotely or in person, the type of infrastructure we use, how we deploy code. And then also at the very bottom are the core beliefs that gave rise to the structures, patterns, and events. So for example, when I do this modeling about a bug in production with people, the mental model at the bottom is almost always something like, we have to go fast or we'll never make any money. We have to be fast, we have to do this quick, this is all that matters. And they don't realize that the constant pressure to hurry up, 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 is actually creating a system that is frail. It is also then, the pattern is we don't actually have time to improve the system, we're just adding more to it, and we end up with bugs in production. But we don't think, and especially as an architect, we don't pause and consider, how have we generated this? When you engage in a system at the level of a paradigm, the most impactful thing you can do is recommend a change in mental models. If you recommend a change in mental models, it will scale up to improve the structure, patterns, and outcome. You don't do this all the time. You don't even necessarily do it often, but to ignore its necessity means that we'll keep building another factory. So again, when Donella Meadows says systems can't be controlled, but they can be designed and redesigned, this is what she meant. She meant understanding the root cause of our challenges and not just reacting to, as if it's a constant fire drill, to every experience that we consider a failure. So there is a bonus sixth skill, six practices, and that is being really good at building tech, right? We do need our technologies. They're like, we're scientists in this way. We do need to understand our tools, right? That is important. And I know for myself right now, my team and I are working in a technology stack that I have never worked in before. I don't know if this was wise, but we were doing apps and web, so we chose Flutter in Dart. And now I'm actually experiencing the repercussions of this choice. Still seems right, but I'm always learning. I'm always improving my tech skills. But imagine what you could accomplish with these 5 qualities and practices, plus very strong technology expertise. How much more impact you could potentially have in your own mind, in your teams, in your organization, and in the world around us. So expanding your thinking tool set, practicing metacognition because we are knowledge workers, be excellent at systemic reasoning, focus on relationships, shift the paradigm when necessary, or at least consider doing so, and be really great at building tech. I wrote a book And if you want to go deeper into this, afterwards I will be at the book table to sign books, answer questions if for whatever. We still have about 5 minutes, so we'll have time for some questions, but if you have more, definitely do come and find me. Also at learningsystemsthinking.com, we're building a community. There's a systems library where we're adding more and more resources for you to understand different perspectives, because my view is only one. All of the speakers here really were contributing. If you synthesize the different points of view that you're experiencing here, you're going to come up with much more knowledge than you would from any one of us. So we are demonstrating that for you here. Great. Thanks again for joining